In this video, we are going to see about normal distribution. The main objective of this video of normal distribution is to learn about this continuous distribution, normal distribution, where 68, 95, 99.7 rule can be applied. We can also use a standard normal distribution using the standard normal table, table B given at the back of our textbook. We can also find the inverse normal calculation using the table as well as using TI-83, 84 graphing calculator. The normal distribution is a density curve. It is described in continuous variable. It is bell-shaped, symmetric, and defined using the mean, mu, and standard deviation sigma, with the equation of the density function to be f of x as 1 by root 2 pi e raised to negative half x minus mu by sigma the whole square. The bell-shaped curve will look like this, where the center of this distribution is the mean mu, and how it is variated, how it is deviated from the mean is described by sigma. The second diagram here is also a bell-shaped curve with the mean mu. The standard deviation here is less than the previous one because it is not much deviated. It is a peak curve. So when the curve becomes peak, then it looks like the deviation will reduce. The normal curves are used to model many biological variables. They can describe a population distribution or a probability distribution. Let's see this family of density curves. We have three curves here. One is peak and the red one is flat. But it looks like the center of the three curves is the same, say almost 15. So it says that the means are the same with mu equal to 15. The standard deviations are different, 2, 4, and 6. 2 may be the standard deviation of the blue one, and 6 the flat curve red one. For the second set of family of curves, it looks like the centers vary. The center of these distributions vary, but the standard deviation is the same because the shape of the curve is the same. And I can say that the mean is 10, 15, and 20, whereas the standard deviation is 3, the same throughout. We can also use this app to understand the concept. When I shift this curve to the right, it looks like the mean changes because the center of the curve changes. But the height doesn't change, so the standard deviation is the same. When I shift it to the left again, the center varies, so the mean varies, and the standard deviation does not change. Here, if I'm trying to move the curve upwards, the center is not affected, so the mean is the same, but the width reduces. It becomes a peak curve, so the standard deviation reduces when you move the cursor up. When you compress it vertically down, that is when you move it down, again the center is not altered, the mean doesn't get affected, but the standard deviation varies. So the standard deviation does not change, but the mean increases as the apex is moved to the right and decreases as it is moved to the left. The mean does not change, but the standard deviation decreases as the graph is stretched vertically and increases as it compressed vertically. Let's say the 68, 95, 99.7 rule, which is also called the empirical formula. The 68, 95, 99.7 rule is described this way. It is applicable for all normal curves with mean mu, standard deviation sigma. 68% of this data lie between -1 sigma to +1 sigma. So let us take the center to be the mean of this curve. that is mu, and it is not deviated, mu plus 0, and the one which is to the right will be mu plus 1 sigma, mu plus 2 sigma, mu plus 3 sigma, etc. The same way you can have values to the left as mu minus 1 sigma, mu minus 2 sigma, etc. And 68% of the data lies between negative 1 sigma to positive 1 sigma. 95% lie between negative 2 sigma to positive 2 sigma. And 99.7 lies between negative 3 sigma to positive 3 sigma. So you have mu minus 3 sigma, mu plus 3 sigma here. Most of the value lie between mu minus 3 sigma to mu plus 3 sigma. So it's 68% of the observation are within 1 sigma of the mean. 95% are within 2 sigma of the mean. 99% are within 3 sigma of this mean. So suppose if the values lie outside these values, we can make use of the table B as well as. So if we have a normal curve which is described by x as mu and sigma, n of mu sigma, then the center will be mu plus 0, mu plus 1 sigma, mu plus 2 sigma, etc. So you can easily find how these values are distributed using the 68, 95, 99.7 rule. So using the 68, 95, 99.7 rule, let us try some problems here. The respiratory rate in newborns vary approximately normal with mean 50 and standard deviation 5. So it looks like there is an X which represents the respiratory rate, which is normal with mean 50 and standard deviation 5. So let us draw a normal curve with mean at 50. So we can construct 3 points to the right because maximum lies between negative 3 sigma to positive 3 sigma. This is my mean, mu. There is no variation here. So there is 1 sigma, 2 sigma, 3 sigma, negative 1 sigma, negative 2 sigma, and negative 3 sigma. Now 95% of the data will lie between negative 2 sigma to positive 2 sigma. 95% always lies between negative 2 sigma to positive 2 sigma, that is between 40 to 60. So approximately 95% of that lie between 40 to 60. Next question is, what approximate probability is that between 65 and more? So again we are using the same normal curve. 55 and more will be this shape. 55 and more is the region lying to the right of 55. 50 is the center. So if this is the center and if I take this as the vertical line through the mean, then between negative 1 sigma to positive 1 sigma, you know that 68% of the data lies. So this will be 34%, half of 68. So this is going to be 50 minus 34, which gives me 16%. What is the approximate probability between 50 to 55? Sorry, 40 to 55. 50 to 55, this is the center. 50 to 55, we know that this is half of 68, which is 34. Between 40 to 50, this is negative 2 sigma. So this is half of 97, which is 47.5. So when we add this will be 47.5 plus 34 will be the answer for this. So that 47.5 plus 34, which will be 81.5. Since we are trying to find the probability, we have to write this as 0.815. Again, here it is not 16% since we are trying to find the probability here. Let us write that as a decimal, 0.16. The pregnancy length in horses. It is approximately normal with mean 336 and standard deviation 3. So we have to use the 68, 95, 99.7 rule. We can construct a normal curve with mean 336 and standard deviation 3. So the center is 336 and 3 points lying to the right with an increase of 333. So 339, 342, 345 to the left. We have 3 points where we are reducing 333. We know that 99.7% lie between the negative 3 sigma to positive 3 sigma. So this is 1, 2, 3. Here I have negative 1, negative 2, negative 3. It lies between negative 3 sigma to positive 3 sigma. So it will lie between 327 to 345. The second one is what percentage of horses' pregnancies are longer than 339 days. So we are trying to find what this area is. 336 is the center. This is 1 sigma. So this part is half of 50, which is 34. So since this is the middle, we know that this whole thing is, the right hand side is 50, left hand side is 50. So this will be 50 minus 34, which is 16%. But here you are asked to find the percentage only. So you can write the answer as 16%. For the answer for the first question is 327 to 345. See, 327 to 345. Let's see the next question. We are trying to find, there are two sets of things here. One for women and the other one for men, hemoglobin rate. For women, it is approximately normal with mean 14, standard deviation 1. For men, it is with the mean 16 and standard deviation 1. So we have got two sets here. We can construct two separate diagrams for this, one for men and the other one for women. What percentage of women have more hemoglobin than men's mean hemoglobin? Men's mean hemoglobin is 16. So we are trying to find what percentage of people are above 16 in the women case. That is if you calculate that, that will be the answer for the first one. What percentage of men have less hemoglobin than women mean hemoglobin? Here for women, the mean is 14, but you are asked to find what percentage of men are below that region. What percentage of men have more hemoglobin than women's mean hemoglobin? So what percentage is above 14? You can easily calculate those results. Now let us try to see the necessity for table B. The table B you can find from your textbook from page 685 to 686. The table B looks like this. It says it is a standard normal curve where the first column represents the z values and the one what you find inside, they all represent the area. you have from two pages, one starting from negative 3.4 and then the other page it ends with 3.4. In fact, it is negative 3.49. And always when you use this table, you can find the probability only to the left of it. The table, whatever you see here, gives the area to the left. If you are trying to find the area to the right, then you subtract that from 1 because the total probability is always 1, so 1 minus. Now when you want to use the table, you need a z-score, where z is x minus mu divided by sigma, where mu is the mean of the population, sigma is the standard deviation. We are trying to standardize this for so that you can make use of the table. You need a score, z-score, which is x minus mu divided by sigma. So when we use the z-score, naturally, if you have x equal to, you have z equals x minus mu divided by sigma. You had this thing, you had z, the z-score z is x minus mu divided by sigma. So at this particular point, you know that your x, originally x was 0. So when I substitute, sorry, x is mu. When I substitute x as mu, mu minus mu by sigma becomes 0. So this point becomes 0. So that's why we are representing this by the standard normal curve. So this is my standard normal curve. So for a standard normal curve, the mean is always 0 and the standard deviation is 1. So we denote that by z, which is normal, with mean 0, standard deviation 1. All other properties of the normal distribution will follow here. That is 68% lie between -1 to +1, 95 lies between -2 to +2, and 99.7 lies between -3 to +3. Because this mu plus 1 sigma becomes 1, mu plus 2 sigma becomes 2, and mu plus 3 sigma becomes 3 here. Let's make use of the table to get this result. So using the standard normal curve, we have to find these values. So when we want to find z less than 1.85, maybe 1.85 is somewhere here. This 1.85 does not coincide with 2. So I cannot make use of that 68, 95, 99.7 rule. I have to use only the table. So if I want to use the table, I go with the table there and then search for the results which are less than 1.85, and the same way you can get. Let's try to find the the standardized value z that satisfies the following condition. The probability is 0.8 that a randomly selected observation falls below z, and the probability is 0.35 such that the selected observation falls above z. So for the first one, less than z, I need 0.8. So maybe I'm trying to locate a point somewhere here. So let us assume that this is the point I'm interested in. So to find this point, I have to search for 0.8 inside this curve. So 0.8, I don't have exactly 0.8. I have 0.7995 and 0.8023. Now 0.8, and so maybe this is closer. So I will select this. So that corresponds to, here this side it is 0.8 and here I have got 4. So this corresponds to 0.84. See? So the area to the left is 0.8. And hence the z value is 0.84. So that is the answer for A. For B, the area or the probability above that particular point Z is, so I'm looking for a point Z such that the area above this, the shaded area above that is 0.35. But when I'm using my table, I can only use the area to the left. So if the area to the left will be 1 minus 0.35, which is 0.65. So I have to look for 0.65 here. See, I have only these 2 points. So the closest will be 0.39. 0.3 and then 9 here. For the fruit fly, the mean is 800, standard deviation is 0.075. Now, what proportion of male fruit flies have thorax length between 0.9 and 0.1, sorry, 1 millimeter? So, if I am trying to make use of the table, I need to standardize this. I need to get the z-score. So, z-score formula is x minus mu by sigma. The mean is 800, standard deviation is 0.078. So the z-score will be x minus 0.8 divided by 0.078. And when x is 0.9, I can find what is z value. And when x is 1 millimeters, I can find what z values. So in this, I have this point to be x equal to 1, but the corresponding point in for z distribution is 2.56. So the same way, if I'm using my table, I can easily find the area lying to the left as 0.9948 using the table. And for x equal to 0.9, I got the value for z as 1.28. So area to the left is 0.8997. But the question here is, what is the area between 0.9 and 1? That is between z is 1.28 to z equal to 2.56. So if I subtract one from the other, I get the answer as 0.0951. Now, since we are using the table, we are not getting, there is a slight discrepancy. Maybe if you are using a graphing calculator, you may get the result, so you can choose that as the answer. Now, approximately 16% of male fruit are shorter than what? So yeah, I have to find what is the z value such that it is less than 60%. The same way, we can find what is the z-score, and then making use of the table, you can find that it is 16%. 16 for area to the left is 0.16, so you can get the value for z, and then you can calculate the value for x here. The same way, for the area lying to the left is 30, so you can find what is the corresponding value of z here. Then you can make use of the formula to get the x value. But to get the x value here, it is a laborious process of using all algebraic operations. For z equal to x minus mu by sigma, you know the value for mu, you know the value for sigma, you know the value for x, but this is what you have to find. So you have to solve for x and get the result. Now those problems can be easily done using the graphing calculator TA83 or 84. Now when you are trying to use the graphing calculator, we have to remember two important keys what we are going to use. If we are trying to find the area between some lower bound and upper bound of normal curve, say the lower bound is given, the upper bound of that region is there, then make use of this formula, probability of L less than a lower bound less than or equal to x less than or equal to upper bound is the normal CDF lower bound, upper bound, mu, sigma. Suppose if you have a curve and if you are trying to find the area, complete area lying to the left of it. So the lower bound is negative infinity, the upper bound is here. You can also have curves of this form. See, if I'm interested in this, the lower bound is known and the upper bound is positive infinity. When you are using positive infinity and negative infinity in your calculator, you have to enter this key E99 to make use of an infinite value using the scientific notation. So in your graphing calculator, you can search for second variables. Use this key second variables, which gives you the distribution, and number 2 is your normal CDF. If you're trying to find the x value or the z value, you will know you need the area to the left, but here the area to the left must be in decimal. Then in that case, you use the key inverse norm area to the left in decimal, mu and sigma, where mu is the mean and sigma is the standard deviation. So in your calculator, again, if you are using second distribution, the inverse norm key is the third key. So for this particular problem, let us find the human pregnancy is normal with mean 266 and standard deviation 16. What percentage of pregnancies last less than 270, less than 270, 266 and 266 is the center, less than 270, so you have a points approximately 270 somewhere here. You are trying to find what this result is. So normal CDF E99 to lower bound, upper bound, because this is negative infinity, lower bound, upper bound, the mean 266, standard deviation 16. So you can use your calculator and get the result, and the answer will be 0.5987. For the second question, what percentage of pregnancy lasts between 240 and 270? So if you're trying to find between 240 and 270, use normal CDF, the lower bound is 240, upper bound is 270, mean, standard deviation. Enter that in your calculator, you get the answer. The last question, how long the longest 20% of pregnancies last? So for that, we need to find the top percentage is 20%. But when we are using the table or the calculator, we need the area to the left of it. So the area to the left is 80%. We have to use the second key inverse norm, area to the left in decimal, 0.8, 266 is 16. Use your calculator and your answer is 279.47 days, or it is more than 279 days. Now, how to find the quartiles? In any distribution, whether it is a normal distribution or any distribution, you know that here the center is the median. Mu, mean, median, mode coincides at the center. So mu is the mean, and that is also the median, and that is also the mode for a normal curve. So the center is the mean, median, and mode. You have two more points. So these 3 points, Q1, median, and Q3 divides the whole distribution into 4 equal parts. So the area lying to the left of Q1 will be 25%. The area between Q1 and the median is 25%. Area between median and Q3 is also 25. Area between Q3 and the upper value is also 25. Now if you are trying to find the quartiles, it says use the standard normal distribution. So if it is a standard normal distribution, you know that for Z, So this must be, let us take this as Z. Z is normal. It means 0 standard deviation. 1. So if I am trying to find what is Q1, I will use the inverse norm 0.25 area to the left, the mean and the standard deviation. So Q1 is negative 0.6745 and Q3 will be positive 65745. So for this next question 22, we use the same question for by using the table. Let's see how to get the value for the same question using the calculator. It is very easy. Suppose if I want to find the proportion between 0.9 to 1, I can simply use normal CDF 0.9, 1, 0.8, 0.078 because that is the mean and standard deviation. So you get the answer as 0.0947. For the next question, approximately 16% are shorter than what? So the area to the left is 16%, which is inverse norm of 0.16, the mean and standard deviation. So you get the answer for X. 30th percentile. When you talk about the percentile, it looks like 30% lie below. So if you take a normal curve, 30% of this lie below this. That's what is meant by 30th percentile. So you have 0.3, you are looking for a Z value here. You are looking for a Z value. I do not know what the Z value is. So when you are looking for the Z value, you can make use of inverse norm 0.3, 0.8, 0.078, which will be 0.7590. So in this video, we learned about the normal distribution. We also used the table 68, 95, 99.7 rule as well as our graphing calculator. If it is 68, 95, 99.7 rule, it will exactly fit in negative 1 sigma, positive 1 sigma, negative 2 sigma, positive 2 sigma, negative 3 sigma, positive 3 sigma. If it doesn't fall under that category, you can either use the table which is given there in your textbook or the graphing calculator. Among these three, using graphing calculator is the easy method to do. So this video helped us to understand what a normal distribution is and the various techniques of solving problems under normal distribution chapter. Thank you for listening and thank you for watching my video. Thank you.